look forward to hearing your input and answering your questions. Please note, if you are watching today's webinar with a group of colleagues, you will be able to provide a list of additional participants following the presentation. This ensures every attendee will receive a Bentley Learning Unit. I am delighted to introduce Wentao Zhang today. He is one of our success factor advocate here at Bentley, as well as technical support engineer Bikash Majumdar. This Using Excel with STAAD and RAM TED Talk will run for approximately 30 minutes, and we will stay on the line to respond to your questions, so keep them coming. Your phone lines will be muted. Please type your questions in the Q&A box as they come up. We want this to be an interactive session for you and look forward to seeing your questions. Now, I'm happy to turn it over to Wentao to get us started.
Hello everybody, my name is Wentao Zhang. I'm the product manager for our interoperability solutions that is sharing data amongst not only our portfolio of application but also externally as well, and in this case Excel. So the topic of today's talk is using Excel with STAAD and RAM. Let's get started with the agenda. First of all is the motivation. Why? Just because we can do something doesn't mean we should. And in a couple of slides, you see that's a resounding yes for integrating Excel with STAAD and RAM. Next, I'm going to discuss the difference between native versus programmatic approach and what I mean by that. And in each product, STAAD and RAM, I'll cover the native and programmatic approaches that's available to us. And finally, I'll touch on where to get help if you want to explore this topic further. So why, right? So we as engineers, we've all used and created numerous spreadsheets in our working lives, right? So Excel is the original analysis, design, and report workhorse. Let's look at some of the pros of Excel. Number one, of course, is flexibility. You can modify any cell and link any formula as you please. But there's a flip side to that. It's a double-edged sword, so to speak. There's a con to that as well. And because it's so flexible, complexity creeps in. You get a spreadsheet that grows increasingly unmanageable. Some pros to using Excel on its own is custom write design formulas on the fly. You're not really stuck with a black box feeling. You can do tabular formulaic driven structure. As engineers, we love tables, right? And you can also do custom reporting of results as you see fit. You're not stuck with the reporting format of existing analyses and design applications. Those are the pros, but there are also cons. Incapable and not practical, or even infeasible of doing complex FEA with Excel alone. There's really no logic checks, and it's prone to human errors. You can have cells linking to other cells on a different sheet or even on an entirely different workbook. It's just too hard to manage. So with the advent of analyses and design applications, dedicated analyses and design applications such as RAM, Structural System, and STAAD Pro, we've largely taken care of the cons side of things here. So we can do finite element analyses. Point number two, we deal with complexity in that if a certain element in one module change, it flows on to the next. We also deal with logic checks and is less prone to human errors. So what we really want is a best of both worlds. We want to incorporate the pros of using Excel, but without really the cons. So what that means is we want to take RAM and STAAD, combine it with Excel, and together it forms a very powerful productivity combination. And so going back to the question, should we integrate with Excel? And the answer is a resounding yes. Doing this so would add an incredible tool in part of your toolkit in your engineering office. So broadly speaking, I've categorized two ways to, for any application to interact with Excel. I call them native versus programmatic. What do I mean by native approach? So a native approach is a easy built-in feature or even a workaround to allow some sort of data transfer to Excel and hopefully sometimes back, right? So there's simple manipulation without involving custom code. Now, opposite to that is the programmatic approach. So should the suppliers of your analysis and design software choose to, they can expose a API or a application programming interface. What that allows you to do is you can tinker with the application without interacting with the graphical user interface. That's the idea, and provides the ultimate flexibility and power. If you're just using the tools, so we have a vibrant community online on B communities for both OpenSTAAD and RAM Data SS. So they've supplied these tools, they created these tools. If you're just using the tools to hit run, do something with it, you don't need programming knowledge if you're just using these tools, okay? But if you, anytime you need to tinker, modify the tool to bend to your will, you would require some rudimentary VBA programming knowledge. Okay, so let's look at, I'm going to start with STAAD Pro and cover a couple of native features. So these are the native Excel features in STAAD Pro. So the STAAD Pro Product Management team are aware of our preference for tables, and the way we've built our STAAD Pro UI reflects that we do have tables, right? So we got nodes, column tables, and other geometry tables. It allows you to directly manipulate these results by typing values in the tables. Furthermore, we allow copy and pasting to and from Excel, a column, or even an entire table. So what I'll show shortly is this curve truss in Excel, what it looks like when plotted, and we want to try to get the structure into STAAD Pro, and I'll show you briefly how to do that. Another way, natively speaking, without writing any bit of code to get to interact with Excel for STAAD Pro, would be its reporting capabilities. So playing with the report option, we can generate a table. With that table, similar to what we saw before, we can do copy and paste. And once in Excel, you can customize, sort, filter, change color as you see fit. Okay, so now I'm going to jump on over to my STAAD Pro. Right here, I got a blank model. So I'm going to go to Structure Wizard. So I'm going to illustrate the first example I showed. I'm going to add a Pratt truss. 0, 10, and 0. Okay, so I got a truss in here. It's missing a couple of members here, so I'm going to add these two nodes, right? So in my table editor, 0, 10. Okay, that one node right there. Next node, 50, 10. Okay, now I want to add beam to connect them. Okay, very good. So we're nearly there, but because we're dealing with formulas in Excel, it would be nice if they're sorted, because I added these nodes in, right? So what I can do is we can sort these nodes. So I'll go to View, Front View, select these nodes on screen, Node Tool, renumber nodes. At first I want to sort by the y-axis first, y-coordinate, and then x. I'm going to hit accept. You're going to watch this 41 is going to change. Okay, to 22. So now it's nicely sorted. You saw before I was inputting numbers on here, but you can also copy and paste entire columns in here as well. Okay, so now what I'm going to do, I'm going to jump into my Excel spreadsheet. Right here. So here, this is just a simple spreadsheet where, for example, I can modify these parameters, right, and I get a different structure going. And this column just corresponds to the core values, wide core values for bottom and top. That's it. Okay. So I'm going to copy this column across. Control C, O-Tab back into STAAD Pro. You can type values in here if you like. So I'm just going to go Control V. you map to whatever column you want. In this case, the column in memory is column Y, so I hit OK. And just like that, we got that curve structure as defined in Excel into STAAD Pro. Okay, so that was showing method number 1 of manipulating nodes and interacting with Excel natively without writing code. Okay, so next I want to show the other example, which is getting report data out. So I'm going to jump to a previous model that I have loaded and analyzed. Just run the analyses again quickly. Now go to post-processing mode. Okay, and we can see we want to export these node coordinates, let's say, right? So I go to select node. Okay, so you already have results here for you. You can copy and paste this to Excel as you see fit. So what I want specifically, node displacement. Okay, so you can still sort in here as well, but if you want ultimate flexibility, this is what you do. Okay, so we have a table here. Select this table, jump into Excel, open any sheet, Control V. So our data is in here. Now you do what you normally do: insert a table, ensure this is checked. My table has headers, and you got a table to play with. Play with the colors, however you like. And in here, you can sort and filter as you see fit. If I have more low cases, let's say I'm really interested in low case 1, I can tick that. Okay, so it's completely flexible and up to you. All right, so that's the couple of native features when dealing with Excel for STAAD Pro. Next one I'm going to cover are the programmatic features, right? So for STAAD Pro, its programmatic features is exposed via Open STAAD API, Open STAAD Application Programming Interface. Right? So it allows you to incorporate data or drive STAAD Pro from beyond the graphical user interface using programming language such as Excel VBA. So this example I'm showing is what we're doing is we're leveraging STAAD Pro analyses results, but we're using your own design spreadsheet. So STAAD Pro already have an extensive collection of design codes. But let's say you wrote your own, or you have your own design routine that you prefer to use. We can have the best of both worlds. You can have the analysis results in STAAD Pro and design as you see fit. And I'll show you how that's done. Okay. So I jump back into STAAD Pro. I'm going to open example 8. Okay. So I got a simple frame here, all right, and my design spreadsheet. Just loading up. Right here. So this is just a design spreadsheet for a single reinforced concrete rectangular beam. Okay, so it takes input for bending moment capacity. It does its checks, it runs its formulas, as you would expect, from any design spreadsheet. So normally you would input the results, length, etc., anything that you need into here by hand manually, right? But what we want to do is we want to automate this process. Okay, so here I'm interested in member number 14. I want to get his results in. I select get results, and you see it automatically populated the low case. Members start in values, worked out overall sagging moment, and this sagging moment here, B28, is the input that goes in here. Okay, B28, and from here you do your design. All right, so that's a very powerful feature right here, and it's really quick. Okay, and this example comes with STAAD Pro installation. It's under samples model OpenSTAAD. So just then it might have been a lot of moving pieces concurrently, so I thought I'd jump into a simpler example just to show what's going on. Okay. So if you're starting from scratch, right, and you're working with macros and VBA, step number one is to go in Excel is go to File, Options, Customize Ribbon, and make sure Developer is ticked. Okay, make sure this guy is ticked. So Developer is ticked. Hit OK. With Developer ticked, you got this ribbon shown to you, which has a Visual Basic editor. Okay, and also the ability to add in buttons, right? So a button, you can click a button and it runs something, okay? And what does it run? It runs whatever code you put into this Visual Basic editor. So here I got another simpler example. The previous one had a lot of moving parts. This is quite simple. It takes member number, a distance along the member, the locase, and actions on the member. Okay, so trying 14 again, 1 meter in. Okay, I got result. Actually, that might have been imperial units, right? So if we want to dig into what's actually going on in here, you will right-click the button, go to Assign Macro, because one's already been assigned, and then we go to Edit. So in here we have the VBA editor. So this is 10, 15 lines of code to accomplish just then, to quickly get results out into STAAD Pro, right? I'll run through briefly what's going on. Later on, I'll do one from scratch. So this line here is pretty much boilerplate. So we're getting a STAAD Pro object. This here is assigning cells row 2 column 4 dot value. So that's saying cells row 2 column 4 locase value number 1. Okay. So whatever I type in Excel, it's been assigned to these variables: locase, distance, and member. Okay, right, so now we've got a STAAD Pro object. So what does this mean? What's this get intermediate member for set distance? This really long word, okay? So what you do is once you have a STAAD Pro object exposed to you, you can look up things you can do with it, okay? So here I can go into Object Browser. If you got STAAD lib Bentley, right? So under Tools, you want to go to References. You want to make sure this is checked. STAAD lib Bentley allows you to browse the available functions to you. Okay. So in here we have OpenSTAAD, output, and then we can dig into documentation if you like. So I'll quickly jump on over to Internet Explorer to show what that looks like. Okay. So this is the OpenSTAAD documentation. Okay, you got a main page, you got various modules you can drill into. So let's say analyses, results, members, okay, get intermediate, member, displacement, etc. All this is available to you, and even sample VBA code as well. I highly recommend you to just copy this, copy and paste into your VBA editor and try it out. Okay. So over here, I got a similar example, but this case, instead of pulling actions along a member, is just pulling support, right? So to draw a button, you would go Insert Button. I can just draw any button here. I'm creating a new VBA macro. So this is VBA 101. Okay. So if I go message box, hello. Okay. So if I click this button, it's going to say hello. Okay. Now we've got a way to interact with us. What about ways to get items out, right? So remember we saw cells before, that VBA keyword. So you can type cells. open bracket, it asks for row index, column index. This is a way for you to refer to certain cells within your spreadsheet you want to work with. So you can pull values out or push values in. So for example, I want to say low case, right? That's A1. So it's row 1, column 1. You can run the code by hitting F5, right? This runs this routine, or you can just hit the button. So that says low case. So that's referring to that cell, all right? Now you're asking, okay, so how do I modify values in a cell? Very simply, you just go cells, row 3, column 1. I want that equal to 5 instead of 1, okay? So watch this. That went to 5. Okay, so just then, very simply, I illustrated ways to get numbers out of Excel and then push numbers into Excel. And everything in the middle falls into place, okay? So here, again, if we're looking at what is happening here, I've copied out this code, right? This is all that's happening. These few lines of code. At first, I'm initializing some variables and then getting a distance, low case, and then a member number, and I'm passing it to get intermediate member for set distance, all right? So if you're first starting out with VBA in Excel, what I recommend you to do is open up in VBA Editor. Okay, open up VBA Editor. You can place these things called breakpoints, which allows you to run the routine up to a certain point. Okay, so let me go back in again. So I wanna run this code right here. Control C. I'll place a breakpoint. You can just click on the edge right here, place a breakpoint. Okay. Now when I hit this button, okay, it runs to this point and it stops for me and it's asking me the values, right? And then it allows me to query the values. So you see low case refers to that cell, support nodes refer to that cell. Okay, and now we can run line by line and see what happens. You see? So it's going through that, going through a for loop and adding these values in, like so. Right? And if you turn all these breakpoints off, it runs just in an instant. Okay? Okay? So that's a very quick primer on what's happening with STAAD Pro OpenSTAAD. Now going back to my presentation, so far I've only talked about STAAD, and then what about RAM? So what is RAM's structural system's native Excel features? Okay. So in RAM structural system, we can produce reports. So usually they come in PDF or you print them. But under post-processing, there's a text file option. Okay, and when you do that, you can actually save that report into a CSV file, which looks like so. Right. So there's some semblance of a tabular structure that you could possibly reuse. And we're aware of this limitation, and we've added under Tech Preview a SQL report generator. Right, it looks like so. I'll show you shortly how it looks when we actually run it. And it's still under development, so to speak. It's under Tech Preview. Let's see that in action. So we got RAM structural system here. You got to export geometry to SQLite. Once that's done, you got to SQLite report generator, and from here you can bring in your RAM structural system modeling geometry and even its results from analyses, right? That we want to bring in out here. So I want to generate a report. Takes a minute or two. Okay, now I want to open the generator report by this button. All right, so I'll just run through this very quickly. So very comprehensive floor type data, story data, column data. So all the data that defines the physical geometry of your building, and also analyses results. All right. We'll be adding more and more to this, and it will only get more comprehensive. So instantly you can use this and customize as you see fit in Excel. Okay. So we've covered the native Excel feature for RAM structure system. What about programmatic feature? So similar to OpenSTAAD, the API for RAM structure system is called RAM Data SS API. Okay, it's different to OpenSTAAD in that STAAD Pro needs to be open when you're interacting with it because it's an alternative means to interacting with the graphical user interface. With RAM Data SS API, we're actually manipulating the building's database file itself. So to use RAM Data SS API, your RAM structure system file must be closed. So what we have here, we have some beam designs, and we can pull that into Excel spreadsheet using this beam lister. So let's see that in action. Okay, right here. So similar to before, there's code, running this on the back end. Okay, you get access to interface, you query a model, you query a floor, and you pull in beams, etc. So what I want to do is I just click Load RSS, prompts me to select a file. I hit Open. Oh, see, I was just mentioning that RAM structure system file is open and we can't use it, right? So we need to close that. We try again. So open RAM structure system, and it iterated through all the floors, importing all the beams, including design results. Okay, like so, very, very comprehensive. So all in here. So once in here, you can, of course, you can filter to, I'm only interested in lateral beams, and tell me what sections have been assigned, etc. So this includes stud, let me maximize that, stud length, stud diameter, number of studs, stud segment, etc. Okay. So this is just one example, and it's available online. So we've seen both STAAD and RAM native and programmatic features. Next, you're probably wondering, how do we get more help? Where to from here, right? So for RAM Data SS, there's actually a great write-up by Eric, RAM Data SS Tech Note. We've got this link here. Actually, why don't I just navigate to it right now and show what that looks like. Okay, so our B communities is our online forum or hub, if you will, and we have a lot of content on here. So if you want to explore RAM Data SS, we jump into here. What is RAM Data SS Tech Note? And at the bottom here, you have DA for Dummy, DA Data SS for Dummies, right? It's a Word file, and when open, it looks like so. Okay, it's very comprehensive. It runs you through step by step, line by line, what is happening and how to duplicate what you see here. Okay. And also we've created these tools like merging, model merge and move, estimator, section replace, these useful tools that you don't actually need VBA knowledge if you just want to use its functionalities. All right. So that's RAM Data SS. And if you're already familiar with VBA, for example, you can dive right in with RAM Data SS Developer's Guide. And this is located under, sorry, there's something wrong with this link. This is located in the RAM structural system programming directory. It looks like so. Okay, it's very comprehensive. Anything and everything you can do with RAM data access. Okay, on the STAAD side of things, if you want help, pretty much just BA communities again online. You can just search for OpenSTAAD. We've got plenty of resources on there. It's quite a lively forum, lots of activity, querying questions, and our technical support engineers happily help out to make code suggestions. And also the concrete beam design example we saw is located in the samples folder on your machine right now if you have STAAD Pro installed at this path. And as we saw before, OpenSTAAD have an extensive documentation. At this, it's located locally on your machine as well. When opened, it opens in a browser, and it looks like so. And from here, you can drill in the sample codes for you to play around with, and really, the sky's the limit in terms of what you can do. Okay, so with that, and before we jump into Q&A, I thought I queried the crowd, right? So what I really want to know is what features are you currently using Excel for, or what do you wish you can do with Excel in STAAD and RAM? Please type that into your comments Q&A box. There'll be excellent feedback to our product management team to how we can do our job better. So pretty much start the sentence with, I wish RAP STAAD or Excel can do this, and fill in the rest. Okay, if we can just spend a minute or two doing that before we move on to Q&A.
Well, participants, thank you for attending, and hope you found the functionalities, the OpenSTAAD API and RAM Data Access API as a powerful and useful tool, and that can be used for increase your productivity. Now we are open for the questions to be asked, and all participants, please be ready to get your answer. Please type your question and answer in the Q&A box, and we'll try our best to address and answer all these questions. Thank you. Well, I see some of the questions are pouring in. Let me address one after another. The first one is the question: when can we get more information? Where can we get more information on OpenSTAAD?
All right, thanks, Bikash. Yeah, so I suspect that was asked before I showed the second or third to last slide. So let me go back. Pretty much here. So again, our BA communities page is really lively, and the OpenSTAAD documentation have verbatim. You just copy and paste, and it runs VBA code to test and play out with. And I guess first of all is to establish abilities in VBA first. So I would suggest just a quick Google on VBA primer with these keywords, VBA and Excel, and within an hour you'll be flying. Within an hour you can maneuver around your spreadsheet, pull data in, push data in from external source as well. Okay, it's really quite easy.
Thanks, Renchal. The second question came in: STAAD file syntax. related to this create model, modify model?
Oh, right. Yes. Okay. So for some more experienced STAAD Pro users, you may have interacted with STAAD Pro by directly modifying or writing the STAAD Pro file. And then they have these keywords, joint coordinates or members. But with OpenSTAAD, what you're actually doing, you're not dealing with it on a file basis. You're dealing with it almost on a command basis. So similar to how you work with a graphical user interface, you want to add a beam between two nodes. Then in OpenSTAAD, it will be a similar command. I'm just saying this on top of my head, something like OpenSTAAD.geometry.addBeam, and you add in the two node numbers. So that's how it works, rather than manipulating on a file basis.
Well, thanks. Another question came in as how to customize the RAM output reports.
Oh, I see. Yeah, so we saw the RAM structural system SQL report generator. So that was our effort to try and unlock all the rich tabular data that was stuck in this black box before, right? So we were trying to make this better. So that would be the main way of how you customize your report. So we'll be adding and exposing more and more data in a tabular format. Alternatively, you can go the RAM data SS route, which is complete and ultimate flexibility. So we can query the model and you can customize it as you see fit, right? Similar to what you saw with my the beam lister routine in Excel. I think that links on to the next question regarding RAM column design. Can you do the same thing? Yep. So
Yes.
so there's nothing stopping you doing your RAM column design, because in principle it's exactly the same. It's just a structural element, and what we saw was the beam example. So yes, you can very much do the same thing. Push out your RAM column design report. Yeah, Prakash, next question.
That is a question. Next question. There's a question on RAM concept. It was asked, what can we do with RAM concept?
Yes, I see a couple of questions along the similar lines. Okay, so what we showed today was RAM structural system, which is a whole building analysis and design application. RAM concept, for those of you who don't know, is our integrated slab and design application for PT and RC. Okay, so with RAM concept, there are some semblance of tables, but the question is in which direction. So in RAM concept, you can export out tables that define your geometry, define your loads, etc. You can export that out into a CSV text file, and you can very easily pass that in Excel. But at the moment, in terms of coming in, like there's no official API, so to speak. We are aware of this issue, and on BE communities, I created a workaround, if you will, to import geometry into RAM concept. So to those of you that use RAM concept, if you go to File, I believe the command is import STAAD GCFF, right? So and then that imports a text file that describes a slab. So what I've done is actually an Excel spreadsheet that converts the entities in your Excel tables, your column, your slab, your loads, etc., into this text file for RAM concept to consume, and that's on BE communities if you want to try it out. So that's one way I see of going in one direction, right? Going from going from Excel into RAM concept.
Well, the next question came in as, can you run without launching STAAD? I mean, I think it is asked, can you run OpenSTAAD without launching STAAD?
Okay, so what I've shown, STAAD must be running. It's an alternative to directly interacting with the graphical user interface. And again, that is opposed to how RAM structural system data access works. So RAM data access is manipulating the building's database. So RAM structural system must be closed if you want to access it programmatically, whereas for STAAD Pro, STAAD must be open.
Thanks. The following question that I picked up is what about loads? I think it's meant how to add or manipulate loads in OpenStack. That is the question, I think.
Okay, sure. So with all these, because it's an API and we've got quite extensive documentation, I don't memorize what it is. So if anytime you encounter a question, this is how I'll go about approaching it. So I'll go into STAAD Documentation, and then I'll browse this document, right? So I see here we're talking about loads, yes, and we want to do load combinations, okay? So yes, add load factor, add auto load combination. You can do all of these, create new load combination as you see here. So sometimes the name is quite descriptive, right? So that's all available to you. So not just load combinations itself, you can even add individual loads to members, right, belonging to a load case. So here, add member uniform force. We can drill in here, look at the VBA syntax, how that's done, right? Okay, so all this is possible for you. So that was OpenStack, and likewise with RAM data access. Yes, you can you can add and manipulate loads as you see fit with RAM data access.
Well, the next question is
C# or Python.
no,
Right. Yep. Yeah, I'll take this one, Bikash. Okay, so I got a question here relating to different programming languages. Yeah, you can do .NET. It's exposed. So yes, you can use the programming language you choose.
And
so
another
not
question:
how? VBA. Yep.
How about the sample file XLS in STAAD? Is it something the inbuilt macros that we supply with the installation of STAAD Pro?
Yes. That is located at. Okay, I'll just drag this over here.
Yeah.
So this would be the directory: C user public document STAAD Pro Connect Edition sample model OpenStack. So if I go up one folder, these are the sample files that come with STAAD Pro, and what you want to dig in is OpenStack. And our previous design spreadsheet for concrete rectangular beam cross section is here, and you can play around with that.
Well, another questions, results for deflection and summary forces.
Yes, that's available to you. I'll jump into. So short answer, yes, that's available to you. I'll jump into documentation. So if you're after results, there will be under analyses results. Get no displacement, for example, and then you got VBA code here to copy as well. Okay.
Okay.
I think we've dealt with most of the questions. There may be one or two. There may be one or two that we missed. But don't worry, we are aware of it and we keep track of it. And so after this TED Talk, we will address them. Okay. So with that, so are you happy to let it go, Prakash?
Oh yes. Next question again on RAM concept. I wish RAM concept can export column punching data into an Excel spreadsheet.
No, noted. Yeah, we will let product management know about it. Yep.
Another question I think is already addressed. The question is, any command for output data for structural is still available with OpenStack?
Still, yeah, let's refer to the documentation. Design still, right? Get member design parameter. Okay. All right. So I think there's only one or two that we might have missed, but yeah, we'll follow up after the presentation. So with that, thank you, Prakash, for the Q&A. Thank you to those that attended, and I'll hand it back to Sumit.
Thank you, Venture, for such a great presentation, and thank you all the participants for being with us. Thank you very much, everybody.
Thank you, Ventao. Thank you, Bikash, for the Q&A. We would now like the participant to take a short poll based on today's presentation. Would you be interested in having someone contact you to discuss your project need or schedule a demo? Thank you for everyone's responses. Again, a big thank to Ventao for such a great presentation, and thank you to all of you for your questions and participation. You will find the link to today's presentation in the follow-up email. Please provide us with feedback on today's webinar by filling out a brief survey which will be launched at the conclusion of today's session. And remember, if you watched the webinar with a group, you will be able to provide a list of additional participants following the presentation. Thanks again. Thank you. Take care.